In this particular lesson, we're going to talk about displaying statistical data, so different ways that we can actually display it. So we'll start off first by doing a quick warm-up and then talking about different types of data that you can actually display. So as we go through, let's identify just quickly in the warm-up some examples of bias that are presented in the following statements, because we did bias in our last lesson. So in situation A, it says one survey team's portable machine to measure hemoglobin, which is something in your blood, malfunctioned, and it wasn't checked properly, as it should have been done every single day. So it measured everybody's hemoglobin at 0.3 grams per liter too high. Okay, so that is a measure of bias, or that's a type of bias. And of the three types of bias, we talked about response, non-response, and measurement bias. So in this particular situation, the machine is broken, okay, and it's taking an inaccurate reading of everybody's hemoglobin level. So this is actually a measurement bias. So we're just going to identify that as a measurement bias, okay? So in part B, let's take a look at what type of bias we see here. It says, the question is, given that at the age of 18, people are old enough to fight and die for your country, don't you think that that they should be able to drink alcohol as well? Okay, so this question is actually trying to get a specific response. Okay, and so it's not a measurement issue. Okay, um, we know that the population is people who are 18, just based on the question. Okay, but this question is giving you information beyond what the question actually is. Okay, the real question is, do you think that people should be able to drink alcohol at 18? That's the real issue. Okay. However, by putting in that first part of the sentence that says, given that at the age of 18 people are old enough to fight and die for your country, the person who's asking the question is giving information that is not necessarily pertinent to their issue at hand. Okay? And so they're trying to influence your decision. They are actually asking what we call a leading question. And so this is actually an example of a response bias. Okay? They're trying to so the person who's asking the question is trying to influence the response of the person being asked. Okay, by saying, at 18 you can fight and die, but you can't drink alcohol. Like that's the question that they want, but they're trying to influence the person's answer. So we'll move on. We'll talk about different types of data. So when we're looking at types of data, statistical data that we can talk about, there's three types. Okay, and you need to know what the three types are, and we'll discuss ways of displaying that data in just a moment. So the first type is what we call a categorical type of data. And this is data that's divided into different types or categories, okay, descriptions. So we don't use numbers. Okay, so school subjects. That is a type of thing. So school subjects is a categorical way of organizing information. Movie genres, music genres, car companies. Those are all categorical types. Okay, and so without using any numbers, I can take different vehicles and I can place them into those categories. So if I look out on the parking lot and I say, okay, well, this one's a GM, this is a Honda, this is a Toyota, this is a Mazda, that's a Ford. I can put all of the vehicles into those categories, okay, just by brand name. The second type of data is what we call discrete data. Okay, and discrete data is where we're using whole numbers. Okay, we're not using fractions, but we're using whole numbers. So the other thing is that you can have a combination of data. You can have a combination of categorical and discrete data. Okay, so something can be based on more than one type of data. So let's say, for example, if I go back to the parking lot example, we're using it for counting. So if I have, I have 12 Hondas. I have 13 Fords. I have 7 Toyotas, and I have 3 Mercedes. Okay, those are a combination of a categorical and discrete data. Okay, so the category is the make of the vehicle. The discrete data component is the number of vehicles in each category. Okay, so I can't have half a vehicle So therefore, it is a whole vehicle in that section. So it's used. So discrete data is used for counting. Another example could be how many students happen to like red, blue, green, yellow, whatever. Okay, red, blue, green, yellow, orange, whatever color, that happens to be categorical data. Okay, however, the number of people that like red, blue, green, yellow, etc., those represent discrete data. The last type of data is what we call continuous data. Okay, and continuous data can use a combination of whole numbers or decimals with no breaks whatsoever. Okay, it just keeps going and going and going, and it uses ranges or intervals of numbers. So you could talk about a range of shoe size from size, 0 up to size 15, for example. Okay, or temperature. So in this area, we get temperature ranges of anywhere from -40 all the way up to +40 on the most extreme days. Okay, and so temperature can fall somewhere within that range. Okay, you could also look at student marks or the heights of students in centimeters or their ages, as decimals per year. So, for example, someone's born in June, they could be 16 and a half or something like that. Okay, so continuous data is used when you have areas in between whole numbers. Okay, so usually for things like finance or temperature or height measurement, um, those are generally used as continuous types of data.